We all like to think of our homes as our own little fortress, right? A safe haven from the outside world. But what if I told you there's a constant, hidden war being waged against your comfort, and the enemy is something you'd never expect?
Look, at the end of the day, we all want the same basic thing from our home. We want it to be a refuge, a cool oasis when it's blazing hot outside, and a warm, cozy haven when it's freezing. This isn't just about comfort, it's about our well being, our peace of mind. But sometimes you can just feel it, can't you? It feels like the house itself is struggling. The AC just can't seem to keep up, the furnace is running nonstop, and your energy bills, well, they just keep climbing. It's like your home is fighting this invisible battle, and it's losing.
So, what is this invisible opponent? Well, it's not some big dramatic disaster like a flood or a storm. It's something way more constant, way more persistent. It's the local climate, the daily grind of temperature swings, the humidity, and maybe most importantly, the altitude where you live.
And that brings us to a really specific and honestly a fascinating battlefield. We're going to dive deep into how a high-altitude climate wages this war, using a place like Englewood, Colorado as our case study. Just let that number sink in for a second. 5,371 feet. That is over a mile above sea level. And up here, the basic rules for how things work, especially your mechanical systems, start to change in a big way. Okay, so here's the key. The single most important factor is the air itself. It's thinner, it's less dense. That means there are literally fewer air molecules packed into every single cubic foot. This one simple fact is the root cause of a whole cascade of problems for your home's heating and cooling. This analogy just nails it. Think about a runner trying to gasp for air at the top of a mountain. That's basically your HVAC system every single day. Because the air is thinner, the equipment has to work so much harder just to get the same heating or cooling result that you'd get without even trying at sea level.
And when you put it side by side like this, the difference is just staggering. At sea level, your system is just breathing easy. But at high altitude, it is in a constant state of stress. And this isn't just about how well it works today, it's about how long it's going to last. That constant overwork just chews through critical parts so much faster. So what does this high-altitude stress actually do to your house? What are the common points of failure that break down? Well, let's play detective and look at the top 3 culprits that technicians see day in and day out. First up, the furnace. In high-altitude areas, you often get these wild temperature swings. I'm talking single digits in the morning and then a mild afternoon. All that expanding and contracting, that freeze-thaw cycle, puts immense stress on the metal in your furnace's heat exchanger until it cracks. And this is really, really dangerous because it can leak deadly carbon monoxide right into the air you breathe. Next, let's talk about your air conditioner. The compressor is the heart of your AC, and in thin air, it is working overtime all the time. The numbers don't lie. A brand new AC unit that might last a solid 15 years at sea level could give out in just 10 or 12 years up here. Why? It's been overworked its entire life. And finally, it's not always the big, expensive machine that's the problem. In so many homes, especially older ones, the ductwork is leaking like a sieve. So your already strained system is working its tail off to make this precious hot or cold air, and it's just bleeding out into the attic or behind your walls. You are literally paying to heat and cool the outdoors. Okay, so picture this. The tech comes out, tells you you've got one of these failures, and hands you a quote for a pretty big repair. What do? You're stuck with this awful choice. Do I repair this aging, overworked system, or do I bite the bullet and replace it? This is where a simple but really powerful little tool comes in handy. It's called the $5,000 rule, and it's just a quick little bit of math to give you a financial gut check. All you do is multiply the age of your system by the cost of the repair. It's really designed to stop you from throwing good money after bad. Let's just run through a quick example. Say your furnace is 12 years old, and it needs a $500 repair. Okay, you multiply 12 years by $500, and that gives you $6,000. Since that number is bigger than $5,000, the rule suggests that replacing the whole thing is probably the smarter long-term financial move. Now, it's just a guideline, not a law, but it's an incredibly helpful one. All right, knowing the problems and having a financial rule of thumb is a great start. But how can you actually get ahead of these problems? Let's equip you with a pro-level toolkit. This is the key knowledge that good technicians use to make sure a system is installed right and runs efficiently in these tough environments.
Think of this as your homeowner's cheat sheet, a manual J load calculation. That just makes sure the system is the right size for your specific house, not too big, not too small. Altitude-adjusted charging means the tech is putting in the right amount of refrigerant for 5,000 feet, not for sea level. Duct sealing, that's non-negotiable. You have to stop wasting energy. And finally, please always make sure the work is permitted and inspected. It protects you and makes sure everything is safe and up to code.
So, here's the bottom line. You don't have to be a passive victim in this invisible war. By just understanding the forces you're up against, the altitude, the temperature swings, you can make way smarter decisions and protect the most critical systems in your home.
Your home is always communicating with you. It sends you signals, higher bills, weird noises, rooms that are never quite comfortable. The question is, now that you know about these invisible forces at work, are you better equipped to understand what your home is trying to tell you?